Okay, good day, students. So what we're discussing about today is a trigonometry. So first of all, we have to know what trigonometry is all about. Firstly, trigonometry is talking about triangles. And triangle is a plane shape that has three sides. So we have different types of triangles. We have scalene triangle, a type of triangle that has none of the sides and angles equal. We have isosceles triangle. This is the type of triangle that has two of each sides and two base angles equal. We have equilateral triangle. This is the type of triangle that has all the sides and all the angles equal. We have the right angle triangle, a type of triangle that has its angle equals to 90 degrees. So, and in trigonometry, we will only be considering the right angle, the triangle, as a type of triangle here. So we have trigonometry. So here we'll be talking about, we'll be considering only the right angle triangle. Okay, let's suppose we are given a right angle triangle ABC. ABC. Okay, suppose we are given a right angle triangle ABC. This is the right angle triangle. So we have A, B, C. And this right angle triangle ABC has its right angle at B. This is the sign of right angle. And theta, the angle. So in trigonometry, where the sign of right angle is facing, the side is known as hypotenuse. That means here is hypotenuse. And we are going to represent here with small letter B. We have here B. We have here small letter A. We have here small letter C. So that means where the right angle is facing is known as the hypotenuse. That means this side is the hypotenuse, which is small letter B. So here, where the angle is facing is known as the opposite. And the other remaining side is now known as the adjacent. So that is all about trigonometry. This is a right angle triangle. So here we have hypotenuse, opposite, adjacent. Let's take for instance now, if this angle is here, if this theta is here, that means here is not going to be opposite. Hypotenuse is constant. Where the right angle is facing is normally the hypotenuse and is always the longest side. And opposite changes with the position of the angle. Where the angle is facing is the opposite. Like if theta happens to be here, that means this place is now opposite and the other remaining side will now be adjacent. Adjacent and opposite changes with the position of the angle. So what we're now going to do is we'll be looking for a formula that connects all these sides and the angle given. So this side and this side, this side, this side, this side, and all these angles given. So let's take for instance now, if you are given these two sides and you are asked to calculate for this angle, what you're going to do is we develop a formula that connects all the sides and angles. So we'll be using an acronym, or a mnemonic is what you normally use to remember it, because you cannot get this in any textbook. So I just normally give it to my students so that it will help them to remember. So we are going to have something like this, SOHCAHTOA. So this is what connects the sides and the angle given. So from here, this S stands for sine. O stands for opposite. H stands for hypotenuse. So C stands for cos. A stands for adjacent. So H, another H, is still hypotenuse. Okay? Another T is a tan. And O is still opposite. The last one, A, adjacent. That's the full form of SOHCAHTOA. SOHCAHTOA. This is a relationship that connects the three sides of the right angle triangle and the angles involved. Yeah? Okay. We're now going to use this with the help of this acronym now, or mnemonic. We are going to use it to solve as many questions relating to trigonometry. Okay, so let's now. So from here, we will now have that. If we say that SOHCAHTOA is this, that means we will not be having that. If we have sine from SOHCAHTOA now, that means this side is not going to be, this will be equal to this side. So sine will now be, is opposite divided by hypotenuse. That is for sine. So we are done with so. So the next one will now be CA, that is cos, will now be equals to adjacent divided by hypotenuse. So the next one, we are done with this. The next one now is TOA, which is tan. Tan will now give us a opposite divided by adjacent. So that is for this acronym. It's very important. You remember it, but don't write it in any exam, be it external or internal exam. Don't write it on your answer script. Just have it off head. It's a mnemonic, not a formula. So with this, you can solve any questions on trigonometry. Okay, from this, we've now agreed that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So we can as well relate it to this diagram now. This illustration. From this illustration, we can simply have that sine is equals to, sine theta. Yeah? Sine theta now will now give us a, so from here we have that sine is opposite. Where is opposite? Where the angle is facing, which is C, divided by hypotenuse is what? B. So we have B. So that is for sine theta. So cos theta now will give us a, cos theta is adjacent. Where is adjacent? A. We have A divided by hypotenuse is B. So likewise tan theta from here, tan theta will give us a, so opposite over adjacent. Where is opposite? C divided by adjacent is A. That is for the acronym known as SOHCAHTOA. It's very important. Very important. So the next thing we are going to do now is you have to note that from these relations given now, you have to note that sine theta divided by, sine theta divided by cos theta will give us tan theta. We can simply prove it. How are we going to do it? So we have to prove it from this illustration. So from there, we have that sine theta is opposite over hypotenuse, which is opposite is C divided by hypotenuse is what? B divided by another one. Cos theta is a cos from SOHCAHTOA. SOHCAHTOA. Cos is adjacent. Adjacent is A. We have A divided by hypotenuse is B divided by B. So there is a formula in mathematics known as division multiplication rule. So if you are dividing two fractions, this is the first one, second one, what you're going to do is for you to introduce a multiplication sign. So you have to write the first one like that. The second one, you now write the reciprocal, or you exchange it, you turn it upside down. So this is now going to give us C divided by B times, instead of divide again. So B will go up and A will come down. The reciprocal of this. We now have a B divided by A. So from here we have C times B will give us CB. B times this will give us, so quickly B can cancel B to give us a C divided by A. Okay, we say that sin theta divided by cos theta will give us tan theta. Okay, and the fraction will give us a C divided by this. So let's now check tan theta, the value. From the illustration, we have that tan theta, tan from SOHCAHTOA, tan is opposite. Opposite is C, that right? Divided by adjacent is A. C over A. If you take a look at this, it is going to give us the same thing. So this is a proof that sin theta divided by cos theta is going to give us a tan theta. So that is what you have to know about this. Okay, let's now solve questions on this. Let's solve questions on this, please. Okay, so let's solve questions. Okay, let's take a look at this example now. Example 1. Example 1. Okay. Given that sin theta is equals to 8 divided by 17, full stop. Calculate the values of, we have A cos theta, B we have tan theta, C cos theta plus sin theta divided by cos theta minus sin theta. Okay, so that's what we're going to do. So following the rule of trigonometry, we can easily solve this. And another thing, the next thing or the next formula in trigonometry we are going to consider will now be the Pythagorean Theorem. Before we solve this, we have to take a look at Pythagorean Theorem. So after that, we'll now come back to this question. Pythagorean Theorem states that the hypotenuse square is equals to the sum of the squares of two other sides, which is opposite and adjacent. Hypotenuse square will give you the sum of the squares of two other sides, which is opposite and adjacent. So hypotenuse square, we have Pythagorean theorem. Okay, Pythagorean theorem says that. So let me take it back. Let me repeat it again. Pythagorean theorem states that the hypotenuse square, you know the side that is hypotenuse from that illustration. So it says that the hypotenuse square is equal to the sum of the squares of two other sides, which is opposite and adjacent. Mathematically, this is Pythagorean theorem. Pythagorean theorem states that hypotenuse square, this thing means side. Hypotenuse square will give us opposite square plus adjacent square. Adjacent square, that is Pythagorean's theorem. Pythagorean's theorem. So this theorem was named after a man known as Pythagoreans. He was the one that propounded the theorem, and it was now named after his name, Pythagoreans. He is a mathematician and a philosopher. So the theorem was now named after his name. We will now start calling it Pythagorean's theorem. So that is it. Okay, let's now go back to this question. So having known what Pythagorean's theorem is all about, let's go back and solve this question now. So the first example, given that sine theta is equals to 8 divided by 17, calculate the values of A. The first one, cos theta. Second one, tan theta. The third one, cos theta plus sine theta divided by cos theta minus sine theta. Okay, so at this point, is either you draw a diagram, an illustration of that right angle triangle showing the values given to you, or you can just assume or memorize it and solve. Okay, let's attend to the question. So we have let's draw. This is the right angle triangle. We have something like this. Sine of right angle. That means here is hypotenuse. Okay, let's say right angle triangle ABC. Yeah. So hypotenuse, this is theta. Okay. The question says calculate, given that sine theta. Okay, sine theta is 8 over 17. So from SOHCAHTOA now, SOHCAHTOA. From SOHCAHTOA, sine, they said sine theta. Sine is opposite over hypotenuse. From here, sine, where is opposite? Opposite is here. That means here is going to be 8. 8 meter. Where is hypotenuse? The longest side, where the right angle is facing. So we have here a 17 meter. So we don't know this side. Before we start calculating for this, we have to calculate for the remaining side by using the Pythagorean's theorem. So we don't know here. We can name here as x. So we have to first of all get here before we start solving all this using Pythagorean's theorem. Using Pythagorean's theorem, Pythagorean's rule. So we are going to have, we'll not be having that. Recall that Pythagorean's rule is hypotenuse side, hypotenuse square is equal to opposite square plus adjacent square. So at this point now, so hypotenuse is given. So we are now going to have hypotenuse by substitution. We'll not be having that 17 square will give us opposite is 8. 8 square plus the remaining side that we are looking for, which is adjacent, is x square. So this will now be taking us back to linear equation. So for us to calculate this, we have to collect like terms. This one is an unknown term, we don't know it, and we are looking for it. This one is a constant term. So we have to group all the constant term in one side, either left hand side or right hand side. Likewise, unknown term in one side. So this will now give us 17 square. This will cross over to 17 to give us so it's plus here. Once it crosses over, it will now change to minus. We'll now be having 17 square minus 8 square will give us x square. So from here, we'll now find the square. 17 square is 17 squared is going to give us 289. We have 289 minus 8 squared is 64. 8 squared is 64 is equals to x squared. Okay, so 289 minus 64 minus will give us 225 is equals to x squared. You can as well write it and have that x squared is equals to 225. So at this point, mind you, we are looking for the value of x, not x squared. What are we going to do? For us to eliminate this square here, we are going to root both sides, because this roots like this means 2. There's 2 here, but we don't write it. Like in third root, we normally write 3. Fourth root, we write 4. But this one is square root. There is 2 here. So if we root both sides, that means that square will now eliminate this, because this is an equation. Anything you add, subtract, multiply in the left hand side, you still you have to do it on the right hand side. So if we root both sides, we are not going to have something like this. And this 2 here will cancel this 2. So this and this will go. We are now left with only x. We find the square root of this. Square root of 225 is 15. That means x is equals to 15. So we've gotten this side. We are now good to go to solve all these questions. So we are now going to start with the first one. They said, what is cos theta? What is tan theta? What is cos theta plus sin theta divided by cos theta minus sin theta? Very simple. So let's go. Let's solve all the questions now. So following the diagram, the first question we have here as 15 meter x. Okay, the first question says, what is cos theta? So from there, cos, from SOHCAHTOA, cos is adjacent over hypotenuse, and adjacent is 15. Cos theta is now equals to 15 divided by hypotenuse is what? 17. That is the answer. So B, we have tan theta. Tan theta is from SOHCAHTOA opposite over adjacent. Where is opposite? 8, which is equals to 8 divided by opposite of over adjacent, 15. So that is for the second one. Okay, the third one now, we have C. Third one says cos theta plus sin theta. Remember, cos theta is 15 divided by 17 plus sin theta is what? From the question, they said, given that sin theta is 8 over 17, very simple. 8 divided by 17 divided again by cos theta is 15 divided by 17 minus 8 divided by 17. So at this point, we are going to resolve this separately. We simplify or factorize the numerator and attend to the denominator later. So this is now fraction. We are going to simplify it. So let's do it here. Okay. Okay, at this point now, if we have 15 divided by 17 plus 8 divided by 17, so the LCM of the denominator now is 17. So we are going to have 17 divided by 17 divided by 17 to give us 1. 1 times 15 is 15 plus 17 divided by 17 will give us 1. 1 times 8 is 8. It will now be 15 plus 8. 15 plus 8 will give me 23. So our answer is now going to be 23 divided by 17. So that is for the numerator. We have resolved this one. So we now have to come down. We have to come down. So the denominator is 15 divided by 17 minus 8 divided by 17. The LCM is still 17. So we have 17. So this is going to give us 15 minus 8. 15 minus 8. 15 minus 8 will give us 7, which the answer will now give us 7 over 17. Remember, is a fraction. So we'll now have to come back and have that. This will now give us a 23 divided by 17 divided again by 7 divided by 17. We now have to introduce that formula again in mathematics known as division and multiplication rule, whereby if you are dividing two fractions, you have to write the numerator, the first one, like that. The second one, you now turn it upside down, or you find the reciprocal. So this way give us a 23 divided by 17. So times no more divided by. So 17 will go up. 17 divided by 7. So 17 will cancel 17. This will now give us a 23 over 7. 23 over 7 is the answer to C. So that is it. That is it. That is it. Let's solve another question. Let's solve another question. So example 2. Maybe from here you will now really understand this. From here you really understand it. Okay, the second one now, example 2. Okay. Example 2. Example 2, we have if tan theta is equals to 5 divided by 12 and 0 is less than theta, and theta is less than 90 degree, find one sine square theta, 2 cos theta minus sine theta. So is either you draw, which is very necessary. So you draw, you have this is the right angle triangle. You have this. This is the right of the side of right angle. Let's here be the theta. So from the question they said if tan theta is 5 divided by this, so you just ignore this. This 0 is less than theta and is this. So ignore it. So some students will be confused if they see this kind of thing. Okay, we have 5 divided by, that is tan theta. From SOHCAHTOA, so tan is opposite over adjacent. Where is opposite? Here. We have here as 5 cm. So okay, adjacent is 12 cm. So we now have to use the Pythagorean's formula or Pythagorean's rule to get this side. So remember, Pythagorean's rule says that hypotenuse side is equals to opposite side plus adjacent side, adjacent square. So from here, we are looking for hypotenuse because it's not given. We can name it as x. X square is equals to opposite is what? 5. 5 square plus adjacent is 12 square. So x square is going to give us 5 square is 25 plus 12 square is 144. So x square is now going to give us 25 plus 144. 144 plus 25 will give us 169. Will give us 169. So we are looking for the value of x, not x squared. So we have to root both sides. We root both sides to get the correct value of x. So that this square, these two here, we cancel these two. We now have that x is equal to square root of 169 is 13. So we now have here as 13 cm. So earlier on, I mentioned that hypotenuse is always the longest side. If you take a look at this now, we have 13, we have 12, we have 5. Which one is the longest side? Which is hypotenuse 13. So we are done with this. Let's now answer the questions given to us. The first one is sine square theta. Okay, we have a sine square theta. So this means, what's the value of sine? Sine is opposite, which is 5 over hypotenuse, 5 over 13. So this will now be giving us, this is equals to 5 divided by 13. Sine square theta, we are going to square it. And this square outside here, in indices, in power law, power law, this, everything that is inside, it has share to this square. So we are going to use this to share everything. So this will now give us 5 square divided by 13 square, which will now give us 5 square is 25. 13 square is 169. That's the answer. Okay, let's go to the second one. The second one, we can clear this diagram. The second one, we have number 2, cos theta minus sine theta. Okay, from the diagram, cos theta is adjacent over hypotenuse, and from there we have, okay, adjacent over hypotenuse. So we have okay, the first one is sine, which is 5 over 13. Okay, the second one is now, okay, adjacent over hypotenuse, which is 12 divided by hypotenuse is 13. Cos theta minus sine theta. Sine theta now is 5 divided by 13. The LCM of 13 and 13 is 13, so we have 13. 13 will divide 13 to give us 1. 1 times 12 is 12. 13 will divide 13 to give us 1. 1 times 5 is 5. So we now have 12 minus 5 will give us 12 minus 5 will give us 7. 12 minus 5 will give us 7. So our answer will now give us 7 divided by 13. So that is all about this. So the next thing that we are going to treat will now be the relations between ratios. So relations between ratios, maybe in our next class or our next video, we talk about relations between the ratios. So ratios here is talking about sine, which is opposite over hypotenuse, cos, which is cos adjacent over hypotenuse, and tan, which is opposite over adjacent. Okay, thank you so much. See you